Good morning, everyone. Today we discuss about preparation and structure bonding in rhenium 2 Cla2 minus. Structure of this cluster is tetragonal prismatic structure. Last class we discussed about the major structural type of the metal halide clusters. In that major structural, one of the third one is the tetragonal prismatic structure. Again, this color of this complex is the cluster is deep blue in color. Again, in this cluster, rhenium in +3 oxidation state with D4 configuration. We already know in the rhenium is D5 series. So in the 5D5, so 6s2 5D5. Again we write 6s2 5D5. So we remove 3 electrons from this, and we are right remove from the first valence is 6s2. Again remove from electron is D5 D5, so it is D4 configuration. So there is a quadrupole bond between the two rhenium atoms. So in the previous class also we discussed this one. So once you check this one, these 4 electrons in the 5d4, the 4 electrons we already know one sigma bond is formed and 2 pi bonds is formed and delta bond is formed, and the configurations is like this. Along bond axis is z axis dz square involved in the bonding and form sigma bond, and the side wave overlap of dz square is the bond axis. The side orbitals are dxyz and dyz. They form 2 pi bonds. And in eclipse configuration and staggered configuration. In normally organic chemistry, we tell about staggered is more stable compared with the eclipsed. But in this case, the eclipsed configuration is more stable. Why? Because in the staggered configuration there is no fourth bond of delta bond. Here we observe that fourth bond of delta bond. So here that's why we told it is a quadrupole bond. So what is the preparation of these complexes? Perrhenate ReO4 minus. This perrhenate ionium is treated with high in presence of HCl. We get that octachlorodirhenate plus 3 ion. So this complex have the structures. It has a eclipsed configuration already told, which is favorable, and the rhenium distance in the 2.24 angstroms. The first class we discussed about what is the major structures, what is the factors, evidences for the metal clusters. In that class we discussed the internuclear distance is less than the sum of radius. So here it is the internuclear distance in this cluster. The sum of radius is 2.75 angstrom units. So that's why the internuclear distance is less than sum of radius. So there is this ion is diamantic. How it is this uh, confirmed diamantic means in the previous class we discussed all the 4 unpaired electrons. So if the unpaired electrons is present in a cluster we called as paramantic. But these 4 unpaired electrons of each rhenium involving bonding one electron from rhenium and then electron, they form sigma bond. Okay, here also 2 pi bond. So here 2 electrons is completed, here also 2 electrons completed, here also 2 electrons, here also 2 electrons. So totally perrhenium 4 electrons and perrhenium 4 electrons, all 4 electrons, and complete rhenium quadrupole bond. So there is no unpaired electrons present in a cluster. So this ion is diamagnetic. Since the staggered configuration is more stable than eclipsed, but in this case, this ion is preferred for eclipsed configurations. We already do know. The previous class we discussed about the dxy orbital. So these are along xy axis, in between axis. So in eclipse configuration only they form positive overlap and form a delta bond. So eclipse configuration is more favorable, which is unfavorable configuration for the any other examples of the particular cluster. Again, the second evidence is the internuclear distance is less than of radius. In the rhenium metal, it is 2.75 angstrom units. In rhenium trinuclear cluster, 2.48 angstrom units. But in this cluster, 2.24. So in rhenium metal, the internuclear distance is double of it the atomic radius. Thank you. Good morning, everyone.